This is a gas engine designed for model RC cars. While there are many parts to this engine, we will discuss the crankshaft, carburetor, and cylinder head.
First, we have the carburetor body. This part appears to have been made via fiber-reinforced injection molding with a multi-piece mold to allow all geometry to be made in one operation. There are multiple pieces of evidence to support this conclusion. The first piece of evidence that suggests this part was injection molded is the presence of parting lines along the vertical axis of the part and around the intake taper. Another piece of evidence that indicates the fiber-reinforced injection molding of this part is the appearance of directional fibers radiating away from the sprue removal mark. The final evidence for this part being injection molded is the sprue removal mark, where the injection molding sprue is cut away from the finished part. The main reason for injection molding this part is the relatively complicated internal geometry and the low cost per part in high production volumes. Injection molding this part also virtually eliminates the need for post-production work or machining. Other production methods for this part include casting and CNC milling. However, casting would require considerable finish machining, which would add time, cost, and weight to the finished part. This part could also be created by CNC milling. However, on a conventional 3-axis CNC mill, this part would require at least 7 machine operations.
Seen here is a crankshaft for the RC engine. This piece translates the reciprocating motion of the piston to the rotational motion. It is a monolithic piece, and we believe it was created using powdered metallurgy due to the rough surface finish on the unmachined parts. Powdered metallurgy allows the use of net shape forming, producing less overall waste since the piece has to be machined afterwards. The machining processes required after production include milling the intake cavity, which can be seen here, and turning to create a smooth surface for bearings and to cut the threads for the flywheel securing nut.
This is a cylinder head for a nitro engine made from aluminum. Its job is to dissipate the heat from the engine into the atmosphere. This part was made with a combination of die casting and CNC machining. The first piece of evidence that it was made from die casting is the parting line along the vertical axis of the part. Second is the rough surface finish due to the cavity's surface. Third is the small draft angle for the separation after cooling. And finally, the complicated geometry. After it was die cast, it was machined for a better surface finish to mate with another part. It also was machined with 5 holes for the fastener screw. We believe that the aluminum was injected from the big ends of the cylinder and was machined off afterward. Alternatively, it can be made solely by CNC machining, but the cost for tooling and the time for milling would be significant compared to die casting for production purpose. Another alternative process could be investing casting, but with such complicated geometry, it would be very difficult to make the pattern and the mold.